Bismillahirrahmanirrahim. Finally, here comes the last article of this chapter, that is limit and continuity of a function. Our learning outcomes will be to evaluate the limit of a function in case of some special function, to determine the existence and values of left-hand limit, right-hand limit and limit of a function, to recognize the left-hand and right-hand limits through examples, to introduce the continuous and discontinuous functions, then to define the continuity of a function at a point and in an interval, and then to test the continuity and discontinuity of a function at a point in an interval. So, here comes the limit. Now, what is a limit? We begin our study of limit by considering examples that demonstrate key concepts that will be explained as we progress. So for that, let's consider a general example of our daily life. Let us suppose that if you and your friend decide to meet at some place outside. I'm just quoting this example that we use in our daily life just to make you clear that what we are about to study. So is it necessary that all your friends are living in the same place and walk on the same road to reach that place? No, not always. All friends come from different parts of the city or country to meet at that one single place. So now let's see how mathematics explain the same phenomena. So we see that it looks like a convergence of different elements to a single point. Mathematically, it is like a convergence of a function to a particular value. It is an example of limit. Now let's see that mathematics explain the same concept. Here is the graph of a function, that is f of x. Now suppose y equals to f of x is a function. Informally, a limit of f is a y value that f of x approaches as x approaches some specified number a. We use the following notation for limit we used to read it as, this notation means that f of x approaches a, limit of L as x approaches a. In the graph shown here, we can see that the value of f of x seems to get closer and closer to y, that is 2, as x approaches to y. Now you can clearly see that the output of this function is 2 when the graph is reaching towards 3. When the value of x is approaching towards 3, the final output, that is L, will be 2. So this is how we can say that limit of this function is 2. Now let's see that how limit of a function is defined in journal form. The limit as x approaches to a of a function f of x is equal to L means that as x gets closer and closer to a from either of the side, either from this left side or from the right side, this is the right side of a and this is the left side of a. So we can say that f of x must approach L. Here f of a does not need to exist for the limit to exist, right? So if you are taking your input as x1, which is towards left of a, and if you are taking your input as x2, which is towards right of a, if the two inputs are giving the same output, or we can say that if they are approaching towards the same value, it means that the limiting value is L and limit will exist, right? Then let's discuss what is right hand limit and left hand limit. If x approaches the number a from the right hand side, as I have told you here that if you are approaching towards this value a, because this a is your limiting value, you will always approach towards this value. And if you are approaching this value from the right hand side, it means it is the right hand limit. Now what is left hand limit? If x approaches the number a from the left hand side, so you used to represent it with a positive, it means that you are approaching a from the right side, and if it is a negative, it means that you are approaching the limiting value from its left. Then let's explain the same concept using a few examples. Limit of a function. How will you be finding limit of any function? For example, if this is a defined function, f of x equals to x square minus 9, x minus v. Now look at the domain of this function. its domain is set of all real numbers except x equals to 3. So it is not defined at x equals to 3. So for this we'll be applying some mathematical solution. We will be solving it algebraically. So you can expand it. You can expand this numerator expression, that is x square minus 9, and you can write it as x minus 3 x plus 3 using a formula. Then you can simplify it. These two terms will be cancelled, and your final answer for this will be x plus 3. Now if you are putting the value of x as 3 in this function, your output will be 6. If we are applying the value of x as 3 to this function, if we are giving our input as 3, our output will be 6. Now if we are giving input to this function as 3, we'll see that our output will be 6. Or if we are applying limit to this function as x approaches to 3, our output or the limiting value will be 6. Now we'll see the same problem as we'll check it for the left hand limit and right hand limit. As the functional value when x approaches to 3 gives us answer as 6. So look at this table. If you are approaching the value of 3 either from left side or from right side, you'll see the behavior of that function. It will approach towards 6, that is its limiting value. So as x approaches 3 from left hand side of the number line, f of x increases and becomes close to 6. You can clearly see and visualize it from these points. And then if the value, similarly as x approaches 3 from right hand side of the number line, f of x decreases and becomes close to 6, that we call it as a right hand limit. We can visualize it from here as well. Left hand limit, that is 3 negative. If you are approaching this 3 from the left hand side of 3, your output will be close to 6. And then if you are approaching the same value, the point 3, from the right hand side, you will see that the output will get close to 6. So we call it as a right hand limit and left hand limit of any function. Then it is existence theorem on limits. When your limit is going to exist. So your limit of that function when x approaches to a exists if and only if its right hand limit and its left hand limit exist and they are equal. So you can say that mathematical notation will be like this. The limit exists if and only if the limiting value, that is the left hand limit and the right hand limit, both of them are equal, then your limit will exist. Now let's see few examples. Evaluate limit of this function when x approaches to 3. And if you are inserting the value of x directly to this function and the answer is a finite value, then you can say that your limit exists. So if you are putting the value of x as 3 in this function directly, you can see that your answer is 1 by 6, which is a finite value. So limit for this function is 1 by 6. Now let's see another example in which when you are applying the value of x as minus 3, it's giving you answer as 0 by 0. So you must have to do something extra because 0 by 0 is an indeterminate form. You can't give exact answer to this question. So for that you have to take few more steps. You can factor out the top and bottom and simplify them. Top and bottom means the numerator and the denominator. So you can simplify them. After few mathematical calculations, you can cancel out x plus 3 and x plus 3. You'll be left with 3 by x minus 3. Now if you are putting the value of x as minus 3 in this function, you'll be getting some finite answer, which is the answer to this function. Now let's see a problem in which the limit does not exist. We have to evaluate the limit of this function when x approaches to 0. Here is the graph of this function. Now you can clearly see from this graph that if you are approaching the value of x as 0 from the left and from the right, you can see that if you are approaching this value 0 from the left hand side, you will see that your output will be negative infinity. And when you are approaching the same point, that is x equals to 0, from the right hand side, you can see that the output will be positive infinity. So it is clear that the left hand limit and right hand limit of this function, they are not equal. So your limit will not exist. And when you have a number over 0, it means the limit does not exist. So if you are solving this problem, if you are putting the value of x as 0, you can see that it is not defined answer. So you will say the limit does not exist.